Hello and welcome to C++ Weekly. I am your host, Jason Turner, and I am picking up with forward like, just like I promised I would from the last episode about reference qualified members. Now, before I continue with this one, I do want to point out that Ben also wants you to know that the original paper for forward like has a little bit more details for things like optimal forwarding of a Lambda capture. But I want to discuss this in the context of that getter that we wrote in the last episode that has const and non-const L value and R value reference qualified overloads for a getter for a thing, and how deducing this and forward like should be able to simplify all of this. This episode is sponsored by JetBrains. Today we need tools that help us work quickly and effectively. CLion is a powerful JetBrains IDE for C and C++ that makes filling this need its main goal, integrating code analysis, refactorings, and a wide range of tools into your day-to-day development. The latest version of CLion introduces deep integrations with the ReSharper C++, Writer C++ language engine, performance improvements for the debugger, new features for embedded development, and enhancements for project models and build tools. Use the code CPPWeeklyCLion to get 25% off when purchasing a new CLion subscription or renewing your existing one. We have our 4 reference qualified overloads here. And we want to use deducing this to simplify the implementation of this, which is a large part of the point of deducing this. This function here I'm creating called getValue, it takes an explicit this parameter that is a forwarding reference because it's auto. Its type is deduced at compile time. It is a forwarding reference. Now, part of the problem is we don't really know what the return type is going to be. And for the moment, I'm going to put this placeholder auto. This isn't correct, but it'll make sense in a minute. I will fix it. This is the basic idea. I'm saying I want to return back value using the same reference qualifier that quote this was using. So I'm going to go ahead and delete all of this, and we're going to have to talk about the return type of this thing. The examples on CBP reference, which I think are fair and correct, and probably the same examples from the paper, is to use a forwarding reference here as well, auto ampersand ampersand, and then we let the compiler apply its reference collapsing rules to get the proper type from this thing. Now, since we do want to use trailing return types, do we want to do that? We might want to do that. And we should be able to get exactly the same behavior by using decal type auto here as well, where the compiler will just preserve the return type exactly from the forward like function. Peeking behind the curtain here is slightly more complicated. We want to say what was the type of the thing returned to me. I can call decal type here and get the type of the thing, and then I can print out the thing returned to me was in fact an R value reference if I use the type trait to verify that it was an R value reference. And if I remove the standard move there, then I should get 0 printed because now it should be an L value reference, const L value reference. Okay, very good. So let's go ahead and these whole type traits and meta programming things are, well, things don't always work exactly how you would expect. I had to drop a reference from the type first to deduce if the thing that was returned to me was const. And this is what I expected. This is a const L value reference. 0, it's not an R value reference, it is an L value reference, and it is const. And if I remove this const from the declaration of obj, then I should get 0, 0 printed. You can see it doesn't matter if I use decal type auto or auto ref ref, it doesn't matter. if I do trailing return type or not. But this is the point of forward like. It says I want to forward this object, self.value, keeping the same type of reference as this thing, which is the decal type of self, which is the deduced parameter for the explicit this parameter from our deducing this that we got in C++23. So all C++23 features. Hopefully I managed to make this make sense in the context of simplifying your getters. And I will go ahead and take the opportunity right now just to say that if this is literally the use case here, if you have literally just a single value, and then I can get this value by const reference and L value reference and R value reference and all of the possible scenarios, this is morally equivalent to the value simply being public and removing the getter entirely. So I'm just saying, if you have full read and write getters on your values in your members of your structs, consider just making those things public, or have some other intelligent controls around the getters and setters that maintain the invariance of your type. If there's no invariance, you may as well make the thing public. But that's a conversation we can have when you have me on site at your company for training. So I look forward to seeing you then. Thanks for watching this episode of C++ Weekly.